I'm Kate.
I'm Kasey.
And our project is on the Minnesota Intercollegiate Athletic Conference softball as an evaluation of statistics for playoff berths and winning percentage. So this was a project that we did for our introductory stats class last spring. So as a brief outline to our presentation, we'll begin by giving a short introduction and background on the project. Then we'll move into materials and methods and discussing some of the results of our research. And then finally, we'll touch on some general conclusions, the surrounding context of our research, and ideas for future research.
Okay, statistics have been used in baseball and softball for many years. An individual player's statistics can be used to calculate a player's worth and salary. Statistics can also be used to evaluate a team's overall success. While the current use of statistics in baseball is extensive, a similar use of statistics in softball is much less so. In particular, there is great opportunity to explore statistics in the NCAA Division III softball and the Minnesota Intercollegiate Athletic Conference. Our primary question was what offensive and defensive pitching statistics were most important for MIAC softball for securing the MIAC playoff berth and predicting team winning percentages.
So in gathering our data, we obtained it from the MIAC softball archives online. So we scraped offensive, defensive, and pitching data from the web. At the time of the project, playoff data existed from the 2008 season through the 2018 season. So it's data from within this time frame that we incorporated into our study.
We chose our primary response variables based off of our primary research question, where we decided to explore two response variables, whether a team qualified for playoffs and the team's winning percentage. We examined the 7 explanatory variables of team on base percentage, team runs scored per game, team walk to strike ratio, team slugging percentage, team fielding percentage, pitching staff walks per hits per inning pitched, and pitching staff earned run average. We then divided the explanatory variables into offensive, defensive, and pitching measures.
So we used two main statistical inference methods to quantify the association between our outcome and predictor variables. So we first used two sample t-tests and confidence intervals to explore a comparison of stats between teams that made playoffs and teams that didn't. Then we also used a multiple regression model with a backward elimination selection process to develop a model for predicting team winning percentage.
As seen in Table 1, our explanatory data analysis resulted in us finding that runs scored per game and fielding percentage were higher in playoff teams than non-playoff teams, while the pitching staff earned run average was lower for playoff teams than non-playoff teams. We then performed a 2-sample t-test for each of the 7 explanatory variables, where we found that there's statistically significant evidence, on average, that on-base percentage, runs scored per game, walk to strikeout ratio, slugging percentage, and fielding percentage are higher for playoff than non-playoff teams, whereas the true mean, walks plus hits per inning pitched, and earned run average are both lower for playoff teams than non-playoff teams.
We obtained a final multiple regression model for team winning percentage as given here, which incorporates the stats of runs scored per game, fielding percentage, and earned run average. So it's interesting to note here that our final model ended up with explanatory variables, one being offensive, one being defensive, and one being a pitching measure. So our model indicated that there's statistically significant evidence that better stats for runs scored per game, fielding percentage, and ERA are associated with an increase in winning percentage after accounting for the other two explanatory variables in this model. Overall, then, our model explains almost 92% of variability in winning percentage. So we were able to use our multiple regression model to make predictions for the 2019 softball season as summarized here for the top teams in the conference. So one interesting thing to note between the actual and predicted results comes from looking at St. Olaf and St. Ben's. And I guess another piece of background information is that playoffs are set up such that the top 4 teams in the conference with the best winning percentage or the best record are the ones that qualify for playoffs. So looking at our actual results, St. Olaf finished tied for 2nd in the conference while St. Ben's finished 5th, meaning that St. Olaf got into playoffs and St. Ben's didn't. Then if we look at our predicted results, the results were flip-flops, so they traded places in playoffs. So although our model, a lot of the results aligned with the actual trends, the top teams in the conference pretty much lined up with the top teams in our predicted results. Discrepancies such as the St. Olaf St. Ben's one indicate that our model might have the ability to identify teams that over or underperform statistical expectations.
Our results suggest that the true mean of on-base percentages, runs scored per game, walk to strikeout ratio, slugging percentage, and fielding percentage for all MIAC softball teams that qualify for playoffs is greater than the non-qualifying teams, and that the mean pitching staff walks per hits per inning and pitching staff earned run average is lower for playoff than non-playoff teams. Our analysis suggests that the most important of our key variables in predicting winning percentages for MIAC softball teams are running percentage, an offensive measure, fielding percentage, a defensive measure, and earned runs against, a pitching measure. Our findings suggest that the runs created approach to offensive statistics. This approach focuses on statistics that creates runs for a team rather than examining strictly individual batter successes at the plate. Our final multiple regression model suggests that as an offensive measure, runs scored per game is a more important statistic than on-base percentage as a predictor for teams' overall winning percentage. This result also aligns with the finding that batting average is not necessarily indicative of team wins. Moreover, 2 of the 3 softball statistics from our multiple regression model were focused on runs than their offensive or pitching counterparts. Based on our data collection methods, it is reasonable to generalize our findings to MIAC softball. Our study, however, has some limitations. It may be that for women's softball, the MIAC is similar to other NCAA Division III conferences, yet other factors such as weather and field conditions may render the generalizability of our findings to all Division III softball questionable. Additionally, as an observational study, we cannot conclude causation. As mentioned, however, our study suggests future paths of research. First, logistic regressions could provide an effective means to investigate how particular statistics may or may not be predictive of whether a team qualifies for playoffs, as well as examine head-to-head matchups. A number of other factors might also be incorporated into future studies, such as potential confounders and seasonal and situational considerations.
All right, that's what we've got.
Wonderful, great. All right, so if anyone has questions, make sure to type them in the chat box. There is one question so far. Someone was wondering, what advice would you give then to the coaches of these teams based on your analyses?
I guess one thing, especially looking at our final multiple regression model, is that it just emphasized the importance of not overlooking any of the 3 sort of major areas of softball, one being offensive, one being defensive, and one being pitching. So while a team might have a really great pitching staff, based on what we've looked at, it's not necessarily going to be enough to come out on top all the time.
Yeah, okay. It looks like another question was, why did you choose softball over baseball for this study?
I think, yeah, Kasey, go ahead, sorry.
As we discussed earlier, statistics have been used in baseball for a really long time, and there has not been as much in-depth studying of statistics in softball, so we decided that we should look into softball in our own division.
Yeah, so while the games are quite similar, there are other factors that do separate them. So I guess one thing for future research, we sort of talked about how Other stats might be included, some things being base running. So the bases are closer together in softball than for baseball. So you end up with a lot more stolen bases, infield base hits, those sorts of stats. So yeah, we thought it would be interesting to look at similar sport that already has some research done on it, but with some variation.
Great. So another question was, could you talk a little more about playoff versus non-playoff teams in your results?
Yeah, so there are a lot more non-playoff teams than playoff teams because the way the conference is set up, only the top 4 teams make it to playoffs, and then the bottom 8 don't. So that, I guess, the reason why we're so interested in looking at sort of that distinction, not just between like what teams are the best or the top half of the conference, maybe the bottom of the half, is because the only way for a team to really continue into the postseason is to make playoffs. So if you don't make playoffs, you basically don't have a shot to make it to the NCAA tournament.
Okay. Another interesting question someone asked was, what was the trickiest part of this project?
I think, oh, sorry.
No, go ahead, Kasey.
I think that the trickiest part was the final multiple regression model, just because it wasn't, the way we calculated it wasn't like we hadn't discussed it in class, so we went out of our way to figure out how to do it so we could apply it to the playoff teams for that given year.
Yeah, I think that I agree with Kasey as well. One other thing that I might mention is just sort of the selection of stats, because as we were looking in some of the literature, things like batting average are often studied, and there are some issues with batting average versus on-base percentage and that sort of thing. We're also looking at like defensive statistics. The most common one is fielding percentage, but there are issues with that too, like trying to judge errors and that sort of thing. So looking at some of the literature that suggested more advanced statistics, I think that we weren't able to incorporate. Looking at some of those, I think, would be really cool in the future.
Wonderful. All right. Thanks, you two.
Thank you.